Hi, this video is all about relationship types in Power BI. We're going to start off with a standard one-to-many relationship, then we'll look at many-to-many relationships. We'll also consider bidirectional relationships and their strengths and weaknesses. Finally, we'll end up with a pattern of ambiguous relationships and we'll solve that. And then we'll look at virtual relationships, those created just in a DAX measure. The problem that we're going to solve with these relationship type is called the nearest neighbour problem, and let's start off by looking at our simple data set. This is our data set. We have a dimension table of 5 home builders. These are all companies which are in the home building sector in the FTSE 100. We have the name, a ticker which is a short code, and the region. We also have another measure which is our indicators. For each home builder, we've got a couple of indicators, return and risk. We've also got a fact table down here that for each of our 5 home builders and our 2 indicators has a row telling the return and the risk of each home builder. For example, Barrett's here has a return of 10 and a risk of 15. Now here's another problem. Each company has a couple of nearest neighbours. So Barrett's has nearest neighbours of Berkeley and Ferguson. But notice that Berkeley's nearest neighbours are not Barrett. Berkeley has a nearest neighbour of Ferguson and Persimmon. What we want to do is we want to compare the risk and return values of Barrett, the direct values, against the average of its nearest neighbours. Let's do that nearest neighbour calculation manually for Barrett's BDev and see what numbers we get. Barrett's direct values for risk and return of 15 and 10. Its neighbours are Berkeley and Ferguson, and the corresponding numbers here are here. If we average the Berkeley and Ferguson risk values, we come to 14.5, and the return we come to 13. So Barrett's direct values are 15 and 10. Its nearest neighbours values are 14.5 and 13%. Notice that its risk is slightly higher, a direct value is slightly higher than its nearest neighbour value. Risk on the whole is more risk is worse, so it's doing slightly worse, whereas its return is much less than its nearest neighbour value. In this case, the kind of higher the return, the better. Now let's have a look at our model pane and notice that we're starting off without any relationships, any joins between the tables in our data model. Let's build our first visual and see how we get on. Let's build a matrix that shows the values of our risk and return against our companies. So I'll click on my company, I'll click on my value, and I'll go to my indicator and I'll click on my indicator name. And it doesn't look very good, and the reason of course is it will tell us there's no relationship. Let's go and put those relationships in, and we're going to use the ticker codes for these. We're going to join from home builder to fact on ticker, a one-to-many relationship, and the same with indicator code. So we've got our 2 relationships here. While we are here, let's hide those fields because we've got them in the corresponding dimension tables. And let's look at our matrix, and it's now looking a bit better. Let's just use the shorter indicator code rather than the name. So it's return and risk here. Now, there's a couple of things wrong with this. The individual numbers are okay. We can see 10 and 15% for Barrett's, but first of all, we shouldn't really be adding return and risk together to get a total. That's meaningless. It is meaningful to aggregate on these row totals here, aggregate over the different companies, but by default it's summing rather than whereas what we would really want here is an average. So let's fix that problem quickly with the sum and change the aggregation to average. But there is a better way of doing this, and that's by creating an explicit measure. Let's do that now. I'm going to put this new measure in an empty calculation table, just a table I've created so all my measures can be in one place. I'm going to click on new measure, and the name of our new measure is going to be called default value, and it's simply going to be the average of our fact value. And there we have it. What I'm going to do is I'm going to replace my implicit measure with my explicit measure. And of course what I've also got to do is make it properly formatted, and I'll format it simply to 1 decimal point. Now our row totals look good still, but we still have the problem of our column totals, which shouldn't be there. Of course, we can go and hide the problem by going into our subtotals and switching off our column totals. But that really just hides the problem, it doesn't solve it. So we're going to do it properly. We're going to go into our default value and we are going to improve our measure. And what we're going to say is we're going to say if, and we're going to use the DAX function has one value, and that will return the tell us true if our indicator code has one value, which it will on each of the rows but not on the totals. And then we can say if it has one value, then we're going to return the average. If not, by default it's going to return a blank. Let's have a look at that. And what we can see is that now we're getting blank values for the total, which is what we want. We can confirm that everything is working as it should be by going back to that tab with our visual tables, and if I click on Barrett Development, we can see that it's filtering the fact table to just those 2 rows for that company. And if I were to control click on risk, you can see that both these dimension tables are filtering this fact table, so there is only Barrett Development risk there. So our direct values are now working. If we look at our model pane, we can see we've got a very typical relationship between our 2 dimension tables, home builder and indicator, and our fact table with one-to-many relationships between the dimension and the fact table. Now let's work out how to do our nearest neighbour, and for that what we need is this mapping table that tells us the links, the relationships between the mapping between our company and its 2 nearest neighbours. We're going to come on to our model pane, and what we're going to do is we're actually going to delete that relationship there, and instead what we're going to do is put in a relationship between the company and its nearest neighbour there. We've got that relationship on there between the ticker and the home ticker, and then if we go to our data page, we can see that in fact this table is actually filtering the nearest neighbour table. So we can see, for example, Ferguson, its 2 nearest neighbours are Barclays and Persimmon. Our next step is to join our mapping table with our fact table. I'm going to go to my modelling pane, and I'm going to say I want to have a relationship between my nearest neighbour ticker column on my map and the ticker column on my fact table. And here it tells us this warning saying it's a many-to-many relationship, and you should only use it if you understand the significantly different behaviour. Well, we don't, but nevertheless we're going to press on regardless. We'll come back later on and cover for our mistakes, but we'll say yes. And what we've got is we've got this relationship which is many-to-many, stars on both sides, and also bi-directional. The filter goes from the map to the fact and the fact to the map. Has it worked? Let's go to our matrix, and now we can see that Barrett has a return of 13 and a risk of 14.5, and if we remind ourselves of our little crib sheet that we did in Excel, we can see that these 2 numbers are actually the nearest neighbour numbers. So yes, it's worked. But we don't really understand what this many-to-many relationship is doing. Under the covers, I believe it's creating a bridge table, and what we'll do now is try and do that explicitly, and maybe we'll come to a more maintainable design. But first, let's delete that many-to-many relationship. Just come here, click on here, delete. I do want to delete relationship, and once that's done, it's no surprise, but our numbers are no longer working. Let's build that bridge table in the query editor. I really just want a copy of my home builder table. I'm going to reference it, and I'm actually only really want the ticker column. There we go, and I'm going to rename this to be my neighbour home builder, and I'll close and apply and go back into the report pane. So here it is. Here's our new table, the neighbour home builder, and what I'm going to do is I will create a new visual table on here, put my neighbour home builder on there. I'll make it the same format as the others, and I'll add a title. There we go. If we select a home builder, we can see that it's filtering the map table, but it's not yet filtering our neighbour home builder table. Let's try and fix that by coming along and creating a relationship between our map table and our neighbour table there. We've created that relationship between the two tables, but when we go back and click on another one, again the map is being filtered but not the neighbour home builder. And the reason is that we've got a single directional here. It filters from neighbour home builder to map, but not vice versa. The arrow is in one direction. So let's change that again with a bit of a heavy heart, because bidirectional relationships are an option of the last resort. What I've put is I put the cross filter direction to both. And if I click on this, then what happens is that we get this double arrow here, and the filter will propagate from the map table to the home builder table. And therefore, if we click on Bi-directional developments, we can see that here in the map table we've got the two neighbours and also just the two neighbours in the home builder table. So that's good. Our final step is to create a relationship between our new table and the fact table on the ticker column of each. And when we do that and we have a look at our matrix, we can see that we're getting our nearest neighbour values. What we've got is the filter propagating from home builder to neighbour map, and from neighbour map to neighbour home builder along the bidirectional one relationship, and then in our final relationship from neighbour home builder to fact. But we've solved one problem. We've got our nearest neighbour values, but we've created another. We've lost our direct values. Let's go and recreate those direct values now. What we'll do is we'll come along to our model pane and we'll recreate that relationship that we had at the very beginning between our home builder table and our fact table. And there it is. And then when we look at our data, what's happened actually is these are actually our direct values, 10 and 15, rather than our nearest neighbour values. And what we've actually got in the model is we've got this awful thing called an ambiguous relationship. The path from home builder to fact can either go directly between the two tables, or it can go from via the mapping and the neighbour home builder table that way. We don't really want ambiguous relationships. They are awful, and what happens is Power BI is using precedence rules to take the shorter route and the route without any many-to-one relationships, and so it's using that. Let's make this relationship an inactive relationship. It's just here, and by doing that, what we've got is we've no longer got that ambiguous relationship because we've got this inactive relationship here. So again, if we look at our numbers, those are again our nearest neighbour numbers. Now let's create a measure to take advantage of that inactive relationship so we can get our direct values. By the way, I've just renamed this. It was called default measure. Better name is default value. I should have done that at the start. Let's create our new measure, and we're going to use our calculate, and our calculate takes a base measure which is going to be our default value, and it changes the filter context in some way, and this way we want to say actually don't use the active relationships but in fact use the inactive relationships. We've got to give it the two sides, two columns. One is the home builder ticker column and the other is the fact ticker column. So that is our new measure, and let's see if it's worked. I'll take my new direct value, I'll put it on the values, and here we can see it seems to have worked. For Barrett developments, the default value, maybe we would call that the nearest neighbour value, is 13 and 14.5, and the direct values are 10 and 15 as we expect. Let me just come on to default value, and what I'll do is now that is really the nearest neighbour value, so I'll say that. So we have our direct and our nearest neighbour values, and that's all looking good, except that we've had quite a lot of cost in the complexity of our model, we've had to create this new table, and in fact we should make that invisible because we don't want to see it in our field list. We've created this bidirectional link here, we've created this link here, and we've had to make this relationship here inactive. There's an alternative way to do it using a DAX function called treatAs and virtual relationships. Let's have a look at that now. So before we do that, let's get rid of the things that we're no longer going to need. I'm going to actually delete this table that we created in the query editor. I'm going to delete it from the model, and that also will mean that those two relationships are deleted. And as a result, if we have a look at our matrix, our nearest neighbour values are no longer working, and if we have a look at our other tab, this was the visual for the table that we just deleted, so let's just remove that visual. Let's build that measure. For a start, let's remind ourselves about this NN value measure, and really it is just the average of the value column in the fact table. What we would like to do is, now we've got this relationship between the home builder ticker and the home ticker, which we would like to say we would like to treat the values selected in this nearest neighbour ticker column as if they were applying to the ticker column on the fact table. We'd like to treat those values here as if they were this column. Let's go ahead and write that measure. Let's create a new measure and let's call it this rather technical name, nearest neighbour treatAs value. And what we're going to say, we're going to use calculate, and our base measure is going to be our nearest neighbour value. But what we're going to say, we're going to use treatAs, this very useful DAX function, and we're going to say treat as the values. We have to give it a table, and the table that we're going to give it is the values of our nearest neighbour ticker column on our mapping table, and those will be selected. Those will give us the nearest neighbours when the home builder is selected, and we're going to treat it as it was the fact ticker column. So let me close my brackets and let's see how that works. Let's go back to our matrix page. I'll drag on our new measure into our values, and we can see that these treatAs values are working. If we remember, Barrett's were 13 and 14.5, those are the correct numbers. I'll remove that old NN value, we no longer need it. Now if we look at our model pane, we can see that the pattern is somewhat simpler and arguably better. Finally, let's create a few measures on top of our direct value and our nearest neighbour treatAs value and a couple of visuals. I've just added 6 measures that are in our calculations table here. Let's have a quick look at them. First of all, I've created a measure called direct return, which is just the direct value filtered where the indicator code is returned. So that's just going to give our return values. Ditto direct risk is very similar, both based on direct value. Then I've created nearest neighbour return, again based on this time the nearest neighbour value, the treatAs value, which is one that works at the moment, and the nearest neighbour risk, again this one same as but filtered on risk. Finally, I've created a couple of measures that are simply differences. The premium return is the direct return less the nearest neighbour return. It's the amount of return that our company gets over and above the average of its nearest neighbours, and a ditto for risk. Let's put those into a simple visual. This is a scatter plot. It shows each company. We've got the tickers, so each company is at a point. We've got the indicator on the legend, which is either risk or return, the blue or return, the red or risk, and we've got our direct value on our x-axis and our nearest neighbour value on our y-axis. What we could say here is that if we were looking at the blue values, it's better to have be in the bottom right, where your direct value is higher than your competitors or your nearest neighbours. With the red values, it's good to be up here in the top left, where your risk is less than your competitors, than your nearest neighbours. That's quite a complicated visual to understand. I prefer this one. We've just created a simple table and we've calculated this premium, put on the premium risk and premium return. For each of those, what we've done is we've added some data bars in our conditional formatting. We have a look at our premium risk. We've added some data bars, and because more is worse with risk, we've given it a positive bar of red and a negative bar of blue. So we could say that on the whole, Barrett's is doing worse. These are all fictional values apart from the company names and company tickers. Everything else is completely fictional values, whereas Ferguson is doing the best because it's got a lower risk than its nearest neighbours and it's got a higher return. So we've seen how we can use lots of different relationship types and how we can bring them together to solve a data modeling challenge. We've actually got lots of videos about data modeling Power BI on our YouTube channel, so I hope that you can join us for our next video or indeed one of those videos.